So we have a horizontal rod that's held against a vertical wall by a pivot. So I'm going to quickly draw that. So there's the vertical wall, here's the pivot, and there's our rod. The weight of the rod is 22 newtons. So there's the weight. And it's held in place by a bar at 60 degrees, providing a tension of 50 newtons. So there's the bar, that's 60 degrees, and we know that that tension there is 50 newtons. Find the horizontal and the vertical components of the reaction force of the rod against the wall. Okay, so what we need to consider is the vertical direction and also the horizontal direction. Now, I would say vertical is a little bit nicer because it's more obvious what forces are acting in that direction. So let's start with that. Well, it's going to be some component of this tension because the bar is, of course, pushing the bar upwards effectively, but also pulling it into the wall. So we want to figure out what component is pushing it upwards. Well, you can see this little triangle here. Let's use SOHCAHTOA. This side is the adjacent, so it's going to be 50 cos 60. Okay? Then, what else do we have going vertically? We have some form of reaction force coming from the wall. So let's say RV, V for vertical, R for reaction force, and then also this bit going downwards, so plus 22. So this is going up, this is going down, okay? Because, of course, the bar is trying to push it upwards. If there wasn't this reaction force here, then the bar would just go upwards because this is greater than 22. Okay, so we know that this is acting downwards to resist the motion of the bar going up. Okay, because friction always acts in the opposite direction. Okay, not friction in this case, reaction force. So, right, we can solve for RV then. So, solving this, of course, you just do this, take away this, and that gives you RV equals 3, and then it's a force, so it's going to be in newtons. So now we need to solve horizontally. So what do we have horizontally? Again, we're going to have some component of this 50 newtons, and that's going to be acting into the wall, and then we'll have the reaction force going horizontally, going out of the wall. So we'll have 50 sine 60 is equal to sine 60 because this side would be the opposite, so sine, because we know the hypotenuse. So then equals RH, where H, I'm saying basically the reaction force, but the horizontal component. Okay, so then what does RH equal? Well, it'll equal 25 root 3, which is correct, but not how we would tend to give forces. We would tend to give it as a decimal. So let's say 43.3. And then this again is a force, so it's going to be in newtons, and we're done. So a ladder is stood upon a rough horizontal floor. So rough, the floor's got some friction, leaning against a smooth vertical wall. Smooth, there's no friction from the wall. Given that it has a mass of 12 kilograms and that the reaction force from the vertical wall is 29.4 newtons, find the coefficient of friction of the floor. Okay, so the first thing I would do with this is draw a diagram, just because it's going to help you visualize where all the forces are going. So let's draw the floor, there's our wall, and then we'll have our ladder in between, which has a weight of 12 kilograms, a mass of 12 kilograms, so we'll have a weight of 12g. Okay, what other forces have we got acting on it? It says that the reaction force from the vertical wall is 29.4. As there's no friction or anything, we know that it's just going straight out like that. So 29.4 newtons there. What other forces do we know? Well, there's going to be some reaction force here, and we also know that there's some friction. If you imagine the ladder sort of wants to slide this way, doesn't it? And remember, friction opposes motion, so friction will be going that way. So we'll have F there and R there. Okay, so we can think vertically first of all. What forces have we got acting vertically? Well, we just got R and we have the ladder's weight. So straight away we can say R is 12g. So that's when we resolve vertically. Okay, what about horizontally? Well, we have F and we have this 29.4. What is F? It's F is less than or equal to mu R. Yeah? So we already know what R is, and this is what we're trying to find. So we're going to set this equal to, well, less than or equal to the force here. Okay? So we're going to have 29.4 is less than or equal to mu R but we already know what R is, so we'll have 29.4 is less than or equal to 12g mu. Okay, so now we've just got a relatively simple linear inequality to solve. So I'm going to divide by 12g, and I'll get 29.4 over 12g is less than or equal to mu. If you stick this in your calculator, it just comes out as 0.25. So we've got 0.25 is less than or equal to mu. The reason this is an inequality, not an equality, is because notice it doesn't mention anywhere in the question that the friction is limiting. So the friction isn't at its absolute maximum. So it could actually be slightly greater than this if needed, but friction only exerts the amount it sort of needs to oppose the motion. If this friction was much higher, that would so if it was at its max, it would mean that the ladder is actually moving this way, which obviously isn't true because it's not going through the wall. So it's an inequality rather than an equality because the friction isn't limiting.